Good day, viewers. You are welcome. How to solve these nice functional equations where we have f of 2x minus 1 divided by x minus 3 equals x squared. I want to solve for the value of f of x in this. So the first thing we're going to do is we consider the solution from here. Then in the given questions, we have 2x minus 1 divided by x minus 3. The first thing we must know here is the value of x here is not equals to 3. And if x is not equals to 3, then it implies that the other value of x are a member of real number. So let's try and consider this domain. Domain of function f is 2x minus 1 divided by x minus 3. Suppose I let everything here, which is 2x minus 1 divided by x minus 3. Suppose I let it to be equals to t. So if I let it to be equals to t, then I want to make x the subject of the formula from here. So what I will do is, if I cross multiply, I'm going to cross multiply here. Then we have this as 2x minus 1 equals t into bracket of x minus 3. And I can rewrite this thing as t into bracket of x minus 3 equals 2x minus 1. So let's open the bracket from here. By opening the parentheses, we have t times x, that is tx, minus t multiplied by 3, that is 3t, equals 2x minus 1. And next, let's try and collect the like terms. So this is x, this is x. By transferring this here, we have tx, and here becomes minus 2x. Then let's take minus 3t to other side. So we have this equals 3t minus 1. So by factoring out x from here, we have x into bracket of t minus 2 equals 3t minus 1. So after having this, so the next thing we are going to do here is, let's try and divide both sides by t minus 2. So when we divide both sides by t minus 2 from here, and also here is t minus 2. So here t minus 2 cancel t minus 2, and we have x equals 3t minus 1 divided by t minus 2. So if this is what we have, then when we recall from here, we have 2x minus 1 over x minus 3 equals to t, and everything here is in this function. So therefore, we're going to replace it as we have f of t equals, so instead of x squared, we are going to write it as 3t minus 1 divided by t minus 2 and all raised to the power of 2. So then we are going to expand this. So we'll expand this, and this follows when we have, suppose we have a divided by b raised to the power n. So this equals a raised to the power n divided by b raised to the power of n. At this, we are going to let 3t minus 1 to be square, and t minus 2 having its own squared. So following this rule here. So by doing that, we have this as f of t. This equals, so let's try and expand 3t minus 1 squared. But before that, we have to note something here as well, that let's say we have a minus b squared. So this equals a squared minus 2ab plus b squared. So this shows that when we find this, we are going to have f of t here equals, we are going to have 3t squared minus 2 multiplied by 3t multiplied by 1, then plus 1 squared. Everything divided by t squared minus, so we have 2 multiplied by 2t plus 2 squared. That is what we are going to have for this expansion. So if this is f of t equals, so 3t squared is 9t squared minus, so 2 times 3t, that is 6t, plus and 1 squared, that is 1. So everything divided by t squared minus, so 2 times 2t, that is 4t, then plus 2 squared, that is 4. So here is what we get for f of t. And from here, what will be the value of t for this one to be invalid? So looking at this, you can just say if t here equals 2, that is invalid, which means our t here must not equals to what? Must not equals to 2. And we know that t also is a member of real number. So as far as s is also a member of real number and t is also a member of real number, you can just switch t with x and we have f of x, which is equals to 9x squared minus 6x plus 1 divided by x squared minus 4x plus 4, as x here is not equals to 2 and x is a member of real number. And this is how to solve this problem. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and turn on the notification bell for more videos. See you in the next class. Never stop learning. Bye bye.